They want you going for track. Okay. Because we're excited today. We can't do lacrosse in this district. We currently we can't get enough kids out for our sports the way it is. We don't need to add more sports. We have Sure. Awesome. You're invited. Yeah. Okay. First degree polynomial, a line. Second degree, parabola. Third degree looks like that. Fourth degree, Michael is 100% correct, except when we change some things about the shape and we add in these local extrema, what happens is we get kind of these, hills and valleys, so to speak. Okay, messed up W's. And then a fifth degree is going to look something like this. Yeah. So yes. So what we want to be able to do is we want to be able to take polynomials and be able to see what they look like, visually. We want a visual description. And in order to make that happen, we have to learn about the behavior. Now, here's what's important. These are all positive. What do you notice about how they all end? They all end going up. So, whether the degree is odd or even, if it is positive, as x goes to infinity, y goes to infinity. Now, what do you notice about where they begin? Somebody draw a conjecture. If they start negative, they go positive. If they start positive, they go positive. So how do I tell the difference between whether or not they start negative or positive? If they're odd degree, they will start negative. Why? Okay. If you take a negative 5 to an odd power, will we come up with a positive or a negative? A negative. So therefore, where they start, as x goes towards negative infinity, y would go towards, in this case, negative infinity. If it's odd, it would go towards positive infinity if it was even. So the number one thing I want you to keep in mind today is this. If it's positive, it ends positive. If it's negative, it ends negative. So as I draw the negative ones, they're going to look like this. You can see that all the negative ones will end negative. Sure, it's up to you. Notes are kind of your thing, so whatever you want. So all of the ones in the red end going down. Okay? So let's consider the two that are negative. Like we said, as x goes towards positive infinity, these will all go towards negative infinity. And then we're going to use Jen's idea about the odd degrees. If they are odd, they will start and end in opposite areas. But if they're even, they'll start and end in the same areas, right? Everybody see that? A second degree starts down, finishes down, or starts up and finishes up. A third degree either starts up and finishes down or starts down and finishes up. So even will be the same start and finish. Odd will be opposite start and finish. So it's odd, so it will have opposite start. And if it's even, it will have the same start. So we place kind of the mathematical pieces there. But what I would try to keep in mind is if it's positive, it ends positive. If it's negative, it ends negative. If it's even, it starts and ends same. If it's odd, it starts and ends opposite. So those are the key points I try to keep in mind. We're going to apply those in just a little bit, okay? Here's another thing you need to keep in mind. How many extreme values does a parabola have? One extreme value, and we call that the vertex. In fact, a line has no extreme values. And when you say extreme, we're talking about local extreme values, meaning those are the largest or smallest values in the immediate area. Look at the cubic. How many extreme values would you say that has? How about the fourth degree? We'd have 3. How about the fifth degree? That's 4. So you can see there that little pattern developing. So somebody make the conjecture. Local extrema for a polynomial. Given a polynomial of degree n, there are at most n minus 1 local extrema. I see this is a perfect time. You guys will be doing this stuff over Thanksgiving, and you know, grandma and grandpa and aunt and uncle, they'll be looking at me like, "You're so smart. Like that stuff's just way confusing." And they'll probably want to like give you money and stuff to go to college. Just no, you'll be like, you know what? I am a really brilliant person, and you'd be wise to invest in me for the future. You know, so that's what you say. So. All right. Another piece that we have to be able to figure out when we graph these shapes is the type of roots that they have. So as you look at the cubic, you know, this one happens to cross the x-axis in 3 different places. 3 different places. Now, that's not going to be every time that it crosses in 3 different places, but here's one thing we know. If it has a single root, it passes through just like a line. If you have a root or a solution or a zero that occurs more than once, you've heard this before, maybe multiplicity of a root. Say the multiplicity is 2. I know. Yep. So if it's a double root, then that's what it does. It has behavior like a parabola. It literally comes down and touches tangent and bounces back off. Now, if it's a triple root, then it does this kind of thing. It flattens out right there. So if it has a multiplicity of 3, then that's what it does. So is that a single root, double root, triple root? It's a triple root. How about this one? That's a double. This one? Single. This one? Triple. So let's put this together and then make your brains explode with amazement. Okay? Can somebody guess what degree polynomial this is? It is a 9th degree polynomial. 3 plus 2 is 5, plus 1 is 6, plus 3 is 9. So it has 9 total solutions. It is a 9th degree polynomial. Now, watch. I mean, that looks like a ridiculous polynomial. Like, it's like, I wonder what the equation would be. Not too tough. I know that it has a triple root at -2. So I'm going to put x plus 2 to the third. I know it has a double root at 1. So I put x minus 1 squared. I know it has a single root at 4. So I go x minus 4. I know it has triple root at 7. So x minus 7 to the third. I play around with my window a little bit so I could see larger values. Does that not look like what I have right there? What? I mean, there it is. You know, it's like, that looks exactly like what we have, right? Here's my... Rhiannon wants to graph at her wedding. Wow, that's awesome. That's awesome. So here's what I think's cool about it. It took us like 30 seconds to come up with the equation. It's that easy. So figuring out equations for these things that model what we want is really not that big of a deal at all. It just looks difficult, yeah. So let's flip to your notes. Let's look ahead at what we're doing during this unit. Today, we are starting with polynomials and their graphs, and we're going to teach about that both today and tomorrow. And tomorrow, you have a decent amount of work time during the day to work on your assignment, okay? But you maybe recall dividing polynomials. You maybe recall the rational roots theorem, complex numbers. And then this piece is super awesome, the fundamental theorem of algebra. It's really cool. Yep, the FTC, and for calculus, there's part 1 and part 2. It's awesome. Yeah. Well, he doesn't know how to do it either, so not yet. We haven't gotten to the FTC yet. Okay. Let's graph. What is the degree? Second degree. When we multiply it out, is it going to be positive or negative? It's going to be positive. That means it will end going up. And since it's even, will it start and finish in the same direction or opposite? Same. So that's the type of thinking I believe most students should go through as they try to identify what is this going to look like. We have solutions of 2 and -3. So I'm going to plot -3 and +2. It starts up, it ends up. Now, that's not real surprising. We've sketched a lot of shapes like that before, right? I want you to note that we don't know how far down that extrema value is, but that's not really important to us right now. We're more concerned about the behavior along the x-axis. What is the degree of number 2? Third degree, positive or negative? Negative. So it will end down. It will begin up. Why? Because it's odd, they will start and end in the opposite vicinity. So I have -4, I have +1, I have +5. I was going to say something there. No. It would be very nice, though, so I can't. What degree is number 3? Third degree, positive or negative? Ends up, begins down. And so again, that is the type of thinking that you should carry through. Yeah. as you multiply the x's out, you will come up with a positive x cubed. So I have 0, 1, and negative 5 for my solutions. It's positive, so it will end up. Because it's odd, it will start and end in opposite vicinities. Yep, and it starts and ends in opposite vicinities. It ends down because it's negative. Okay, number 4, what degree? We just have 2 more left. Third degree, positive or negative. And so it's going to end down. It will start up. You guys are catching on? Now, what's unique? What's unique about this one? Yes, you have a double root. And because you have a double root, that will change the behavior. You can see instead of having 3 markings, I only have 2. Because one's a single and the other one's a double. Since the double root happens at -4, it will do that. That's a sad graph. Last one. What's the degree? 4. Positive or negative? Negative. Why is it negative, Terry? There's an x that's negative. And therefore, when you multiply it all out, stop swearing at me, Lauren. Lauren, it's not good to swear at your teachers. If I were your parents, I would discipline you, Lauren. Lauren, don't flick me off anymore. Go. Okay, here we go. So it's negative, so it's going to end down. So it will start down. Because it's 4th degree, it will start end in the same direction. And they are all single roots. So that's my shape. We're going to do a lot of these examples again tomorrow. And you'll be able to work on your assignment in class and hopefully feel really good about where you're at. And then we'll move on Tuesday, okay? Or on Wednesday. So, no homework tonight. They're saying it's a Christmas miracle. So you guys expect an assignment from me every day, right? Rach? Yeah? I mean, you basically know that basically every day in math we're going to get an assignment. That makes me happy. When I was in math, we did get an assignment. I went home sad that day. I'm not kidding.